So for this series, we need to do what's called an alternating series test. Whenever you see that -1 operator, think absolute value test or alternating series test. Now, because this one is alternating back and forth, adding a term, subtracting a term, we need to do 2 steps to either determine convergence or divergence. Now, for our first one, we need to take the limit of just a sub n without this operator that's going to flip it back and forth, and as n approaches infinity for 1 over 7 plus 2n, right? If we take the limit of this, it just omits that operator that's flipping it around, right? So is that series going to diverge, or is it going to converge to one singular point? We notice that this is going to be 1 over infinity, so it's just going to converge to 0. So what this means is that we pass the divergence test, therefore we don't know if it's divergent or convergent, so we can go to our next step, right? If you don't get 0, well, you know this is divergent, no more work is needed. This is a divergent alternating series, right? You're going to add and subtract terms that grow, so you're just going to get a value that is really, really, really big or really, really, really small in the negatives, right? So we pass the divergence test by getting an output of 0. All we have to do now is simply do the next step. Now, for this we take 1 over 7 plus 2n, and we need to ask ourselves, is this always decreasing? So imagine your sequence of your sums as being a function f of n. Now just take the derivative of that, f prime of n, right? So this is a simple quotient rule derivative, so you just say, okay, u is equal to 1, u prime equals 0, v equals 7 plus 2n, where v prime is equal to 2. All right, remember it's v, so it's going to be 7 plus 2n times 0, so that cancels, minus 1 times v prime, which is 2 over v squared, so 7 plus 2n squared. So is our series always decreasing? Think about it as a function, take the derivative. So f prime of n we find to be -2 over 7 plus 2n squared. Now for any value I plug in, 1 through infinity, which is our bounds of our series, we're going to notice we're going to get a negative value because of this negative sign here. And because of that alone, we know that it is always going to be a decreasing value, which means that, think about it like this, we're going to have our first part of this sequence, right? We're going to subtract it by something, right? So we go to this, and then think about it kind of ping-ponging back and forth, but getting closer every time, right? So when we plug in something next and we're going to add it, right? We're going to add something. So this would be the third term, for example, but it's going to be a little bit less because we're always decreasing. We're going to go back, but not quite as far. And what's going to happen is you're going to ping-pong back and forth, until you reach a singular value. All right, so we're going to converge here because we're adding something and then we're subtracting something a little bit close, but not quite the value. So we're just going to get closer and closer, smack into one value. So we know this series is going to converge. Alrighty, because we're always decreasing and we passed our divergence test, we can make that conclusion. Hope you guys enjoyed this video. If you did, please drop a like, comment, and subscribe. I would greatly appreciate it, and I hope that you have a wonderful day.